Well, thank you for joining us. My name is Nikhil Dabare. I'm a cloud solutions engineer with the AWS Device Farm team. I'm joined with Chandra Bomas, the engineering lead for AWS Device Farm, and our special guest, Russ Smith from Rainforest QA. And today we are going to be talking about testing and troubleshooting using AWS Device Farm. So just first question, how many of you have heard about AWS Device Farm? Wow. All right, OK, good. So before I begin and dive into the main stuff, how many times has it happened with anyone in this room where you got all excited about a simple app or some random ad popped up and you said, ooh, that looks like, it could solve my problem. Think about like birthday planner, you forgot an anniversary and an app claimed, I will always remind you everything. And then you went in and said, yes, that's the cure. And then you excitedly downloaded the app, told a friend about it. And then you open the app and you say, OK, log in. Sure, I'll do that. And maybe, unfortunately, the login didn't work, or the app just froze. Or you were able to create the account, but then something started acting weird. Your app maybe crashed. It could be the greatest app in the world after the login page. But if it crashed in the first few minutes, think about the perspective that you get from the app, right? You say, yeah, I wouldn't recommend. And you leave a bad review maybe for the app. Now, pretty bad from the customer's perspective, right? Think of it from the developer's perspective. He's like, yes, I know this problem. I've invested my time. I'm going to put my sweat into it and write this app and deploy it. Maybe the developer got a few physical devices on his desk. The developer used those emulators, maybe simulators, and said, OK, I think I covered the top 5 or 10 devices in the market. And I think it should work across all devices. What's the big deal? I'll just release it and then work on it. Well, does it work that way? No. He goes in and says, well, there's a device out in the wild, a Samsung S5 somewhere, for example, on Verizon that's acting weird. He goes, well, I tested it on Samsung S4, S6, and even an S5. How come it's failing on that, right? So putting a developer's hat, it's a pretty bad experience, right? You thought you tested it on Android, you tested it on iOS, but as soon as you start seeing this wild reviews out there, you're like, OK, how do I solve this problem? So as a developer, I say, you know what? I can fix this. I go out and buy all these new fancy devices. And it's like, OK, I'm going to do a market research, a survey, and get all these devices. And then I plug it in. And it's like, OK, let me start with this. This is my gap that I had. So as neat as I wanted to make this setup, can you see any problems in this setup? Sure, you can have a sophisticated hardware at your home or office or anywhere, and you do all the USB port hubs connected. But as your devices grow, now imagine you did this for a few months, and the new Android phone got released, or new 3 iPhones got released a year. And then you say, oops, I got to buy all of those, right? So you plug it in, you start testing, you have your USB hubs and everything. So what can potentially go wrong here, right? So start thinking about the cases from a developer's perspective. He says, OK, I got it plugged in. I have my USB hubs. Let's see, how do I connect these to all the networks and make sure they stay on the same network? So there's a networking problem. Then you got to make sure that they are all on the right operating system that you want to target. Let's say you had an iOS 10 iPad and iOS 11 iPhone 10, but the bug was reproduced only on 10.3.2, say, for example. Now you say, OK, I got to have one of the devices upgraded. Well, it's a one-way street. Once you upgrade, you can't go back, right? So you have a fragmentation issue. Like, OK, I can deal with this. I'll get an emulator maybe, and you're back to square one again. So how do you solve these problems? So this is some of the challenges if you want to solve it on your own, or if you're trying to think of doing this on a company level or an enterprise level. You're going to have more investment, but it's still a problem, right? And this is just a really small aspect of it. So you're thinking from a developer's perspective that I want to test it and make sure that it's tested across a broad range of devices, and I don't run into issues. As the saying goes from Amir Garhai, he's a famous unit testing evangelist who says, no amount of testing can prove a software right, but a single bug can prove it wrong, right? As I said, could be the greatest app ever built behind the login screen. But if the login screen didn't work, is it useful? So what are we going to talk about today? So we're going to briefly touch on building blocks of a mobile app lifecycle. just to have an overview on when you're just thinking about testing, there's a lot of other parts that could be involved, right? Just writing a mobile app is not just, I wrote the code, tested it, and oh, good to go. There's an entire life cycle, and you may need devices across the life cycle of your mobile app life cycle. Others are, we'll specifically then zero down on the mobile testing space challenges because we're talking about device farm too. So I'll go deeper into that aspect. Then we'll touch upon device farm. And then I'll talk about how can you use device farm. And then we'll have some other customer stories of how they have leveraged device farm successfully. We also have Russ who'll share his insights on device farm and how he has used device farm. So what are the building blocks of a mobile app? On a really high level, you have an idea, like your birthday reminder or your anniversary reminder. You say, OK, I'm going to design and write my app. So you do the whole writing and designing an app. And then you have to test that app. So when you say testing, your tests are not one time, right? You could either do manual testing, automated testing, or you could use some test generation tools present out there. But your tests need to be repeatable and reliable. If your tests work on one case and not the other, when you redo it the next day, they're of no use. The third stage is you developed it, you tested it, now you want to deploy it. So let's say you got your test written reliably. Now you want these tests to be repeatable, right? Because if you're doing it on a daily basis and if you have a continuous integration where you say, OK, I'm going to check in one line of code and I want to see if that affected any of the behavior across the app. So you need a continuous integration deploy system also. So let's say you did all of that, you say your app is ready, then you release your app in the market. Now you want to see how customers are interacting with the app. What kind of data? Are they happy? Are they going to a particular screen? Are they able to achieve what they're looking for? Is there a feedback that I can use? Are they finding bugs? So you want to measure your performance of your app and take feedback. And while that is happening, you engage with the user. Maybe your app is designed to send specific notifications, push notifications, SMS, email saying, we noticed that this happened, have you tried this? Those sort of behavior, right? So you help the user while they're using the app. So you have the engage aspect, and then the cycle repeats, right? It's an iterative cycle. So AWS has services for each layer of this mobile development lifecycle. And to name a few, your development, you could start with AWS Mobile Hub. For your test, you have device farm. For your deploy, you can use code deploy and other AWS tools. For your measure and engage, you have Amazon AWS Pinpoint. So some of the services that deal with each layer, we're going to be focusing more on the test part. So to start with test part, we first need to know what are the challenges across the test space, right? So as I said, the first one, you saw those whole devices that I had on the table. There are so many, tons and tons of devices. I think I have seen every, but I have not. There are devices that you can now completely integrate on your own with blocks and pieces. You have those kind of devices. Just, if you just say, for example, Samsung device, you have like all the way Galaxy, and then you have these layer of manufacturers, right? So name a few, Samsung, HTC, Motorola, LG, and then that's one layer. Then you have another carrier layer. Because Android is customizable, a Samsung Verizon S5 may work differently from a Samsung S5 AT&T because they may have their own apps, own custom layers on top of the device, and your app may be specifically crashing on that one. And so there's a lot of fragmentation. In an iOS, the OS layer remains pretty much the same, but now even iOS has multiple devices each year. So that's a fragmentation problem. Then once you get those devices, you need reliable access to those devices. You have the USB plugged in. You want to make sure they stay up. Your battery doesn't swell up over time. Your displays don't die. Your network stays up. You don't get wild OS update pop-ups on your devices, and that causes your test to not run. Then let's say you got those devices. You say, OK, I have this devices thing figured out. I have all of the other pieces figured out. Now I'm going to write tests. There are tons of testing framework out there. And then you want to know, OK, what am I testing here? Am I testing my backend? Am I testing my mobile app? Because your UI test could be just mobile app interactions, right? So you say, I click on the menu, go to this option, do that. Functional test is more of you're testing the backend. You're saying, is my backend service working? Are my method APIs all good? So that's the testing choices you have. Then, as I said, you have multiple testing frameworks. There are open source frameworks out there. To name a few, Appium, Calabash, they're supported by open source community that help you run on both Android and iOS without rewriting your tests. The other native testing frameworks are Espresso, XCUI, to name a few. So you got to make a choice of, OK, I'm going to do UI testing to make sure my bug was resolved, and I'm going to pick one of these testing frameworks. Let's say you're successful till here. You're making decisions. Good. Now, you say, well, I wrote the app. I invested time. Now, how do I make this repeatable? So you got the whole thing figured out, and you say, can I do this repeatable? How can I make it? Do I need a machine to which I connect 10 devices? Do I make them available over some SSH magic? What do I do? So you need a continuous integration system for mobile testing. And let's say you made a choice in there, too. You say, OK, I got this figured out. Now you say, well, yeah, I have 1,000 tests. I got really good and involved with this. Now the tests that are running, can I get reports from the tests that are useful to me? Because if you have 1,000 logs and if you're successfully running the whole system, is it good enough? Because your one test may fail only on those 4 devices or on 400 devices. But you just want to make sure that you have actionable reports, right? You say, OK, I see the bug, and I know that's what I have to do, rather than digging into logs, correlating stuff, and saying, oh, I think I know the problem. You can imagine the number of hours you can spend just looking and digging into the log for something really simple. So that's the reporting thing. Now, all that said, you still need granular control of devices in all of these phases, right? So you're doing test, deployment. You want to make sure your devices have particular settings that your app may have. Maybe your app requires animation to be turned off or animation to be turned on Android. So you want to make sure when you plug in a new device, that always gets honored. Maybe you want to switch off the Wi-Fi on all the devices in one go and say, OK, I want to run this test. So you need granular control on Wi-Fi. And then your test setup, too. Maybe you don't want to run 1,000 tests. Maybe you just want to run 5 tests, because you know the problem is in that one feature in your app. So you say, OK, I just run those 5 tests. So you need granular control to just tweak it on the fly. So those are some of the challenges in mobile testing space. So here comes Device Farm. So how can you use Device Farm? Device Farm, as the name suggests, is a service where you can get access to hundreds of real devices. These are not simulators, emulators, virtual devices. Real devices hosted in one or more of AWS data centers. And you can use these devices across your development lifecycle. So not just testing. Sure, we're going to talk about testing. But these are devices, right? Well, why would you only use your device or service just for testing? Yes, you're good at it, you'll use it. But these are devices. You want to use them across your mobile app development lifecycle. So that's how Device Farm enables that. So you can use it on a high level in 2 ways, your automated tests and your remote access. Automated testing, as simple as you say, I have my app, I have my test that I wrote, I'll give this to Device Farm, and Device Farm go and run this on the devices that I tell you to run on. So that's how you use automated testing, and I'll be doing a deep dive on the service. I'll show you the demo, how it works. And then remote access. Maybe you just found that one bad review where you had that Samsung Galaxy S5 Lollipop device, and you say, oh, well, I don't have the device. I don't see anyone selling it in the market. There's some eBay shady listing, maybe, that you doubt. You say, I don't want to buy the device and spend money on that. So what do? You go to Device Farm, say, give me that device. And then Device Farm gives you a real access to the device inside a browser. You can play with the device, interact with the device, upload your app, and then see, OK, it's as good as you can do it with an emulator. So if you have an emulator running, you would do an ADB push, maybe, or install the app and say, OK, I can see the behavior. But in this case, you're doing it on a real device rather than a simulated device. So jumping into Device Farm, how do you run tests? Is it visible to the people in the back? Good? Perfect. So I'm in the main AWS console here. And Device Farm lives under mobile branch. So if you scroll down, there you go, not down because I zoomed in. So your mobile service is right up here, and then Device Farm is under there. So I click on Device Farm. Now on a high level, what you see is this card layout. The card layout is essentially projects. Projects are logical containers for one or more of your test runs. So you say, I have this test script, run it on these multiple devices. That's your one test run. So you say projects has multiple test runs, and then each test runs has one or more of your test scripts running on multiple devices at the same time. So let's say we pick a project here. So let's say I pick this one. how do you do automated and remote access testing, right? So let's talk about each one of them. So first, we'll do automated testing. So I say create a new run. Now, as I mentioned earlier, you need only 3 things. You need your application, your tests, and you need to tell us the devices on which you want to run your tests. So you have those 3 high-level tests, and then I'll go into the 4th and 5th step. It's basically how do you control your devices on a more granular level while your test is running. So first, you upload your app. So Device Farm supports both Android, iOS, native, hybrid, and also pure web applications. So if your app was a pure mobile web application where it's not natively written and just runs in a browser, Device Farm is able to test that too. So let's say for the purpose of today's run, we do a native app. So I have an Android app over here. This is one of our just sample apps that we host in GitHub. So I have a pre-built app over here. So I'll say open. Now, while it's uploading, it does a bunch of things in the background. It looks at your app metadata, scans it, and says, OK, I'm going to look at your metadata and see and give you the details of what it discovered from the metadata. So zoom in. I think that's not clearly visible. There you go. So it does a few bunch of things like your package name, your activity. The important ones that I often find customers tell us that it's useful is the min SDK and the target SDK. Because you have hundreds of real devices, right? So you might think that, oh, it will just run on everything. But the metadata just tells you it's going to just run on this target SDK version. So it just gives you a heads up. And if Device Farm finds not a match between your target and the device you selected, it's going to tell you, hey, this is an incompatible device because your app is not written for this target SDK. So it's a good heads up for your metadata analysis. Now you say next. Now, we uploaded the app. Now we want to upload the tests. So Device Farm supports multiple testing types. So we have a few over here. So the first 2 are Explorer and Fuzz. I'll come to that later. But just to touch upon the rest of them, we have support for the most popular testing frameworks, Appium, multiple flavors of Appium, Calabash, instrumentation test, and then an Android instrumentation has Espresso test, the traditional instrumentation test, and UI Automator. If this were iOS, we would still have Appium, Calabash, but then XC test, XC UI test, UI automation. So all of the ones that most people out there use, and we continuously keep on adding testing frameworks as we hear back from customers that, hey, there's a new testing framework, we are using it, so we try and add the support for that. So what is built-in Explorer and Fuzz? So let's say you don't have any tests written. You're saying, oh, it's tedious. There's a learning curve. I'm still learning to write tests. You just quickly want to do a quick sanity check of your app. Maybe all your app is, it's a game that comes up, and you see the login screen, you're good enough because you know everything else is taken care of. Or it could be just an app that you just want to do a quick sanity check. Does it crash when it launches? No? Good. So Explorer will take your app, look, and work within the scope of your app. It's going to look at an app. Say, for example, your app had like 5 menu options. So it's going to look at that and say, OK, I see 5 links. I'm going to pick the first one, and I'm going to try and go as deep as possible. Think of it in from a developer's perspective, think like a depth first. Like, it's going to say, OK, I see the first link. I'm going to go in, look at that page, take the first link, go in. And it's going to try and go as wide as possible and as deep as possible. So that's your Explorer. It runs within the scope of your app. Then we have Fuzz. What if you didn't want to run within the scope of an app? Many times you see when you switch apps, your app is working great, but you switch to another app, and it came back to your app, and then it froze. And you're like, well, what happened? It shouldn't freeze. Is it because of the other app that's causing a problem? Fuzz would induce random events on your device. So it says, OK, I'm going to just have your device be induced with random events across the device, not just within your app. So you think of cases like it will swipe down the notification bar, it will switch between apps, press the back button, maybe turn off the Wi-Fi, GPS, kill some apps out there. So it's pretty random. In short, it just induces random events. And you can see if I change the randomizer seed, it changes the random events that it's going to induce. So for the purpose here, let's say I do a built-in Explorer. Now, by default, it shows you a group of devices, which are the top devices. So the top devices is like a curated pool that keeps it dynamically changing. It could be as soon as a few days, 2 weeks, depending on 2 factors. What most customers are running their tests against, so it could be some popular devices out there on which they're running their tests. So that, and the second factor, what are the popular devices in the market that are being used across the board? So a combination of these two, the top devices pool keeps getting updated. But not everyone would want this pool, so we say create a new pool. So create a new pool opens up a dialog box, and here you can see the first power of device farm, which is just the list of devices across all OS versions, all make, manufacturer, models, carriers. And then you'll see one different thing, which is you see this lock symbol. That essentially means it's a private device. So all of the other devices that you're seeing, those are public devices, as in these devices are shared across customers. When I say shared, it's not that you run your app and, OK, done, and then some other customer will come in. We clean the device all the way. We make sure all of your artifacts are gone. The host machine to which it was connected is completely torn down. We also do sanity checks on the app, make sure the device wasn't tinkered with, there was no root access attempt or anything of that sort. And only when that device is deemed clean, we go and give it to other customer. If for any reason we detect that the device isn't showing the integrity we want it to, that device is quarantined, and we don't make it available to the device, to the other customer until it's run. Private devices are a little bit different because they are dedicated devices. They are only, you tell us which make, model, and devices you want. We go out, procure them, and put it against your account, and they're only dedicated to you. So no one is accessing them. That also gives you more granular control on the device, as in you can tell us, well, don't clean up my device after I'm done running my test. Don't reboot my device. Maybe have this special VPN client on my device. Maybe have this special third-party app that helps me do more analysis on the app. So you can have all of that configuration in private devices. Now, so let's say we select a few devices over here. Let's say OS 6, maybe a Nexus device. Say LG Nexus 5. Let's pick a Samsung S6 maybe, running something 7. There you go. Maybe a LG device, running 5 something. Well, let's pick a private device too. So you can do a mix of both public and private, so you're not only stuck to public or private. You can mix your private fleet with public. Now let's call it my greatest pool. And then save this device pool. So here you see your devices, the ones that you selected. Now next. Now these are the configuration options that come handy for a lot of testing use cases, which is your app or test may have extra data in there. Imagine media files, configuration files that your app or test use on the fly. So you can give us a zip file, say, here's my extra data that my app or test use. And that extra data is extracted to your SD card of the Android device and your application folder in case of the iOS device. So you can upload that there. Other apps, think about maybe your app has a social interaction component where it says, share on Facebook, tweet this. And so when you click on that, it opens another app, which is maybe your Twitter or your Facebook app, and then has everything ready, and you just have to push it. So you want to test maybe that interaction. So your other apps are those apps that your app may be dependent on or use them, and you can upload those too. Next, you can configure the radio states, Wi-Fi, Bluetooth, GPS, NFC. So this is the initial state. When you say, when my test starts running, I want the radio to be set at with these options. Your test, once your test starts running, thereafter it's completely up to your test code or your application to manage the radio states. And Android provides standardized APIs to switch on and off those. Many testing frameworks also provide support for that. This next one is device location. Think about cab sharing apps. Your app works differently when it's near a specific location. Banking apps, give me the ATMs near me. So you want to test those kind of cases. So you can specify the latitude and longitude of your device here. So it populates a default location here. Then this is a feature we recently launched a few months back, which is the host machine in Android. So let's say that you ran your tests. and your testing framework, your choice of testing framework gave you only a certain artifacts. But you think that you can produce better reports, better results, better artifacts by doing some analysis of your own. So you might be producing some binary files, some log files, some Excel files, some dump that you find useful. Typically gaming customers have their game running and they do their own dump of how the game is performing, maybe the frame rate, maybe the GPU and other things. Most testing frameworks may not provide you with that. So you can have all of that, and we'll still retrieve it from you. So you can tell us, here's where my extra files will live. Please go and fetch it from there. And then that's the location on the host machine. On the device, that's when it says Android here, because we selected Android, you tell us the location on the device. It could be maybe, say, for example, SD card. That once my test is done, my XML file containing all the results or my Excel file lives on the device, so you can go and fetch it from there. Device locale. Device locale is the language on the device, so you can choose a language. And then network profile. You want to test your app against lossy connection maybe on a bad network connection, saying, okay, does my app behave properly when it's not in a stable Wi-Fi connection? So you want to simulate those kind of situations. So you get this neat pre-populated network profiles like 3G, 3G lossy, good Wi-Fi, bad Wi-Fi. You can take it a step further by creating your own network profile. It could be that you say, okay, I'll work with the app only until it goes like to a GPRS connection. Anything beyond that, don't crash. That's all you want to make sure. And in that case, you can have those thresholds over here. So I'll just keep the default one. I say next. In the next step, it's just going to tell me how long do you want these tests to run. By default, it lets you run 150 minutes per device. So if you have a test script that has 200 tests, it's going to say, I'm going to run your tests for 150 minutes max on per device. There are two reasons this is done. One is to prevent you from accidental usage, because at times you can imagine you feel that you've tested an app, and your tests are guaranteed to not run in 5 minutes, but on your local device. But as soon as you upload it and run it on a device that you've never tested before, your app could just maybe hang, or your test could just not give you any feedback. In that case, that 150 timeout kicks in and cuts off your run. If you want to go beyond that, private devices support that. We have customers running as high as 8 hours to 10 hours, and their tests just go on running. So this is that summary, and then let's say the next confirm and start run. So while that is running, let's look at, after this is done, in fullness of time here, let's look at an existing run. So this is a run that we just ran yesterday from a workshop. So what it does is I ran instrumentation tests, and I'll show you both Explorer and instrumentation, but this is an instrumentation test, and you see here's the beauty of it, that when I click on it, there was this error on these 4 devices. And when I say 4 devices different, this is the subtest within that group. So it says, oh, this kind of error, I found it in 4 different methods on this device. It could be also across multiple devices. So when I say this error, that failed on 2, GPS wasn't turned on or it didn't respond, it could be either way. Here's the neat thing. I click on that error, it directly takes me to the test, and I can see a video of it. It actually just ran the test real fast, but if I hold here, you can see the GPS is false. That means the GPS was turned off. So you can catch that. And the other neat thing is, look at all these logs. So we have 3 kinds of log: harness logs, device log, and test logs. Now, in normal flow, if you were to run this test, you would have your device log separately, your host machine log separately, and then your test log separately. And you would say, okay, at 1 minute, 1 second, test did this. I'll go back to the host. It responded. It sent something to the device. And you have to look at 3 different logs. Device farm lays it out for you according to time. So it says, oh, something happened here. It is on 5 minutes. That happened. And on device, that happened. So we'll give you the entire sequence of logs as per time as it's happening. So you can actually trace, say, oh, an event went from here to the device. Then device did something and responded back. It makes it easier. And then you can also, just filter based on errors. So like say, give me my device error, or give me my harness error. So it does that. Then we also capture your performance data, like CPU usage, memory, and thread count. obviously, once that app launched and the test died, the memory here didn't get affected. Then the files is all your artifacts that I just talked about. And then we take screenshots of your app. So this is not device farm driven. This is your test code driven. So if your test code has a call that says, oh, when it comes up, does this test take a screenshot? So device farm is going to honor all of those test device frameworks. Some testing frameworks have their implicit screenshots. So they'll automatically just take a screenshot and everything, like XCUI. Open an app, screenshot. Moved, screenshot. Blink your eye, screenshot. It takes a screenshot and everything. So it will capture all of those too. Next, so that's the summary on how device farm runs look. The power of device farm is really, if I go back here, is it's running in parallel on multiple devices over here. See? So it already timed out on one, but if you selected the entire 400 plus devices that we had, it will run on all of them in parallel. So that's the power. So you don't have to wait on saying, okay, I'm going to wait for this one device, something happened. And while it's doing it, so when I click on one of these devices, you see a setup and teardown. Setup is essentially device farm is going to say, okay, I got a test run coming into me. Now I'm going to go and grab an instance of this device. I'm going to make sure that the device has good Wi-Fi connection. It does a check, say, okay, good Wi-Fi connection. How about internet connection? Does that check. And then it says, does it have pop-ups on the device? Yes? Well, I'm going to dismiss those. If it learns about a new pop-up, we try and capture and then dismiss it the next time it comes up. You can imagine pop-ups, stray pop-ups like OS updates coming in, carrier settings coming in. Some Google services unfortunately stopped working, or some other app crash, sample pop-ups. So it deals with all of those. And in teardown, it removes and cleans up the device for you. So that's how the console works. You can do all of these things through the CLI using an SDK, write your own script. Now, I just wanted to quickly touch upon how do you do this in continuous integration. So remember our earlier slide? You got it all figured out, you ran it, but you still want these tests to be repeatable, and you want it to be hooked up in your CI. So device farm has a Jenkins plugin. Now, I'll just walk through this as exactly as how you would do it. So if you went back and said, OK, I just want to connect device farm, it's literally just 3 steps. So I say manage Jenkins, and of course, log me out. All right, so I say manage plugins. In my case, it's installed, so I say AWS device farm, and you should be able to find that. Step number 1 done. Step number 2, I want to tell my Jenkins plugin, here's my AWS account. Go and talk to there. Where's my entire AWS setup and devices is. So how do you tell it? You go to manage Jenkins, configure system. So it's going to ask you for your credentials to your AWS account. So access key and secret key, not your actual credentials. So you create a role in AWS account, say, here's my role for the AWS device farm, and give it this access and secret key. So you'd give that. Step number 2 done. Now you may have an existing project. I have an existing project here, so I click on that. And just to show you here quickly, I click on configure, go all the way down and say post-build step. So you might already have a CI setup that generates your app or generates your tests. All you got to say is run test on device farm, and then that opens up this dialog box here, or addition to the screen, that tells you, just a second, okay, post-build step. So all your projects get synced, all your device pools get synced, your application is wherever your Jenkins is producing it. Run name, there are a few configuration parameters here useful for DevOps. Just to give you one of them is ignore device farm errors in build result. Essentially, if you had just errors because of devices, Jenkins would say, OK, I'm not going to give you false positive. I'm going to save you some time and just ignore those. Rest of the configuration is exactly how it looks. We just you'll find a parity with the console over here. You can even disable video and performance testing in the last section. And just to show you how exactly it runs, I click on the project, say build now. Of course, this is however your Jenkins job might be set up, this will kick it off. And then you can see this. It shows a project trend results, right? So if you have your code check-ins going on regularly, something drops, you can see the trend. You can see the number of tests that passed, failed, and everything. There's your job running. So essentially, that is exactly the steps you would do if you have to integrate it with Jenkins. Literally, there's no other configuration here that you need. So I think I covered the console, the continuous integration, switching here. So we did that. We did that. So now I want to have Chandra, I want to invite him and talk about how one of our customers has used Device Farm in a really new and unique way, and we found it to be really useful. So Chandra's going to give you more insight into that.
Thank you, Nikhil. So this customer is Hothead Games. They are a gaming company based out of Canada. They're a top 100 gaming company, and they have some interesting games, Killshot Bravo. Essentially, so they're a gaming company, so for them, it is very important that the games have a really smooth performance. So FPS must be good, rendering has to be solid, the game has to feel as real as possible when you play it. And they came to Device Farm, and they wanted to have a solution that was agnostic of, they didn't want to have a specific solution for Apple devices and a different solution for Android. They wanted to have a common solution. Interestingly, they used, so as Nikhil mentioned, Device Farm has console, has API, has CLI, has an open architecture. So you can use the console, you can use the power of the console, and you can also write your own scripts and write your own methods to interact with it. So they have chosen a self-testing methodology. Essentially what they do is that the game has a testing component built into it. They have a simple Appium test once the game is installed on the phone. They have a simple script that kicks off the game, which is basically open the app. Once the app is opened, then the game starts running, the test starts executing. They get a video stream, and they also get a data stream that then is sent back to their servers, and they look at the performance of the game. So they are really happy with Device Farm, as the quote says here. So when it comes to games, I said FPS, frames per second, is important. What's also important is what makes that up, right? So frames per second essentially is how many frames did I have in a second. So we know, higher the better. 60 frames per second is the gold standard. But it's important that these frames, happen at an even rate. So as you can see in this slide, the device itself has got a pretty significant impact on the frame time. So here you see three terms. You see frame time, you see render time, and you see game time. So I'm just going to break this down for you guys really quickly. Game time is the amount of time that is used by the game to compute the logic of the game. Render time is the amount of time that is used to actually render the contents onto the screen. Together, they are the frame time. Now, if you have a frame time of 200 milliseconds, then your FPS is going to be, and if it's constant, your FPS is 5 FPS, which is not great. And as you can see, there's a variety of devices, and it's the same game, it's the same code. But if you run it on a Samsung Galaxy S5, it looks pretty good. A Galaxy Grand Prime 4G, oh my God, what happened there? So it also illustrates what we believe, which is that we believe that it is important that when you put all of your hard work into building your app, your game, and now you're about to ship it, it's important that you test it on the exact same device, exact same hardware that your customers have in their hands. And we believe that to be true, and when we see testimonials from customers like this, we feel that our beliefs are validated. So let's take a quick peek into some more detail. So this is on a Motorola Moto G, and as you can see, this appears to be pretty bad. So this green dot that you see over here, let me see if I can bring it up.
It's not actually.
Somewhere over here. See this green dot here? So that is the time that is taken. So when the game starts, there's a scene that shows up. So that's the time that is taken for all the assets to load. It's, typically that doesn't happen all the time. You have a scene, and then the characters move in the scene. And as you can see over here, the frame time is the blue line, and it is all over the place. It's high, which is bad, because we're already at 500 milliseconds, which is really bad. And then it's also pretty choppy. This means that this is giving you feedback. So imagine that you built your app, you built your game, and now you're testing against this device and say, oh, something's wrong. We need to do some more work. And then if you go to the next, so this is much better. It's the same game, but on a Motorola Nexus 6. And if you see over here, again, the asset time takes, the green dot is roughly the same spot. But this is, from a performance standpoint, really good. The frame time is low. The frame time is not spiky. And this tells me that, hey, this game is performing really well on this device. So there could be something specific about the other device that needs to be looked at and worked on. And then if you get this kind of a graph across all the devices that you target, then you have a great game, and your customers have a great time, and all is good. So with that, I'll hand over to Russ. So do you want to introduce Russ?
Oh, yeah, sure. So thank you, Chandra. We have Russ Smith here. He's he heads Rainforest QA. So he's the CIO there. So he's used Device Farm in a really unique way, and I want to have him talk about how he leverages and how does Rainforest QA work. So.
Cool. Hi, everyone. So I'm Russell Smith, CTO, co-founder of Rainforest QA. Quick show of hands. How many of you have heard of Rainforest QA? None? A few? A couple? 1, 2, 3? Cool. Well, short version is that Rainforest QA is a service to help you ship bug-free software. That's our driving goal. Back in 2012, when we started the company, Fred and I, my co-founder, just saw this trend coming that everyone was trying to move faster and faster. So CI/CD was coming, but most of the process that existed at the time doesn't really fit that. So manual QA, difficult to do, as you see, like a cloud of devices on your desk, really hard to deal with. Even if you're doing web-based stuff, that's still difficult to do with lots of VMs and stuff. And automation is generally brittle. It's getting better, but it's still difficult to manage. And you also need engineers to do this. So back in 2012, we started the company. Basically, we're doing it concierge style while we're building it in the background. And so how we work is we use services like Mechanical Turk to get humans to do testing in the beginning on their own devices. And this, of course, caused problems that Nikhil was talking about earlier, which is repeatability. If you're using devices that people have already used before, not clean state, then how do you replicate them? Replicate the issue you find? And the answer is you basically don't unless you're lucky enough to get that human's device back in that particular state. So you may get more bugs, but it's very difficult to debug. And so what we did is in 2014, we spent most of that building out a system of virtual machines. And so what we do is we give the human, the tester, the right machine at the right time with the right software. So the right version of Chrome, the right version of the OS, that kind of stuff. We also shipped x86 Android and iOS simulator to our customers. But I guess you can tell where this is going because it's a device farm talk. Turns out that customers want to test on real devices. So testing on simulators is valuable. Testing on real devices turns out to be more valuable. So I don't know if you know the history of Device Farm itself, but it was actually acquired by Amazon sometime in 2015 and then launched mid-2015. And so by the end of 2015, I and a couple of engineers at Rainforest had cobbled together a prototype of this. And so what we did was there was no remote access at that time, so there was only options for using fully automated testing, which is not what we do. We use humans. And so we had to make a system to get our humans inside the phone. So we wrote an SDK that you just put in with one line and lets us take over the device. So scroll on a little to like 2017, remote access came out from Device Farm. And our belief is that the less you change an app under test, the better. And so what remote access is normally used for is you as customers of Device Farm can just go on Device Farm and say, hey, give me an iPhone 7 with this app running, and then you can use it in your browser, or you can use it from your local desktop. What we've done is a really tight integration with that to put it into our system and give to our testers. And so how does Rainforest work at a super high level? So we have about 60,000 testers working for us every month. We heavily use Mechanical Turk and another system called Crowdflower as well. All of the tests are written by our customers or now professional services in plain English. So there's no code to be written. Integrating with CI or CD is like super common. It's one line, whether you're using Jenkins or code deploy or anything you want. It's really, really simple to integrate with. Most customers are triggering it today via API or the CI or scheduling runs if they're doing stuff in production. The tests, they're storing in plain English, or plain English either in our interface, which I'll show you in a second, or in code in their repo, so plain text files in their repo. And then, as I said before, testers complete the work using a real device connected into their browser. So just like you would if you were doing it yourself. So a little bit about the interface. So as I said, customers write stuff in plain English. You can see here, it's a pretty nice looking interface. This is a recent upgrade. You can see in the middle, you've got a list of tests. This is actually our own internal test suite. Rainforest uses Rainforest pretty heavily. We dog food everything we ship for 3 or 4 years now using Rainforest. Let's dive into it. So this is an iOS device farm test. So every time we do a new release or anything to change with the way we use device farm, we actually retest our device farm integration with device farm and our own internal app. And so this one is a pretty simple test app that we'll get into in a sec. But how do you specify it? Like, all you do is either have a constant URL to an IPA, which you build, so the latest.ipa, or you can specify this at runtime. So we just download this and then start the run. What did the tests actually look like? You can see here, it's completely plain English. These are testers that we've trained, certified on our own platform, taken from mTurk or Crowdflower, and then trained in our method of QA. Once they're good, they get to do production level tests like this. We normally send 2 to 3 testers depending on their ranking. You can see here, if you want to specify different device types, it's just as simple as pressing run or using the CI and then clicking on which devices you want your test to be run on. So you can see here, the person's clicking on like iPhone 6 with some different device, iOS 9 or 9.2. It's really that simple to select what you want. The other options you see here are where we're tunneling the device to. So some of the devices we're able to tunnel out to different locations. So if you want something to be, the tester to look like they're in Australia or in the UK, you can do that kind of stuff too. There's also the option to use an internal crowd of humans. So normally, our customers use our global crowd, which is from Mechanical Turk or Crowdflower, but some of our bigger customers have a giant QA team, wherever that's based, and we can plug that straight into the same infrastructure. So that means you can get the right humans doing your work at the right time. Let's look at what results look like. So let's pretend we've just clicked run. We only ran 1 test in this case, so you can see there's no results come in yet. There's a little bit of info about what's going on, but once you dive into it, this is in the results for an individual test. All of the things are gray at the moment because we haven't got anything back yet, but you can see at the top all of the 4 devices that we selected before. So what's happening behind the scenes? We're taking all of the things you've requested. For each phone and each human that we think we're going to have to send to it, we set up a device farm run individually and wait for the phone to connect to us. As soon as that connects back to us, which is normally pretty quick, we then find the best tester qualified for that and connect them together. And this is pretty seamless. You don't have to do anything at your end. It's pretty complicated orchestration behind the scenes, but it's all seamless. This happens in the sort of sub-minute range, depending on device farm capacity or how many testers are online. We're shifting towards using private devices, private device cloud from these guys, which will make our latency even better. So when results come in, you start seeing real time. You get this tick, a set of things saying that this one has passed. And if we dive in, you can start seeing these screenshots. And these are taken during the run directly from device farm without the tester having to do anything particular. So if we dive in a little more, you can start to see that there's a video. This doesn't actually play. I'll show you one in a minute. But and you can also see details about the tester themselves. If you rate them, you can obviously remove them from your testing pool should you wish. And also on the bottom right, you can start to see the logs that come back from device farm itself. So these, if you integrate with something like Jira or other bug tracking systems, if you have a failure, it's just as simple as pressing export. We'll then put all of the assets we've got from the tester, the report of them failing, the device farm assets such as the video and the screenshots and the logs straight into your Jira tickets. So if you're the one doing triage but not actually fixing the issue, whoever is ending up doing the debugging gets all of the right information at the right time to debug it without having to go back into Rainforest. So this is actually a video taken directly from Device Farm. And you can see, hopefully in a sec, this will start. And it's just literally us testing using our test app to check that the Safari web view still works. And so this, we found, has been brittle for us when we've upgraded OS versions. So we want to do this. So, OK, just a quick high-level recap. So Device Farm plus Mechanical Turk have given us like the awesome superpower of not having to manage that desk full of devices ourselves or doing it in-house. We sit on top of Device Farm for all our native mobile testing. It's been awesome so far. Writing and maintaining code is generally hard, but also so is scaling manual QA. If you're having problems with either of these things, then you should definitely check out Rainforest QA, because we sit somewhere in the middle of both. We're fast, so 30-minute kind of turnaround time, and then the tests are much easier to maintain because they're plain English rather than code, so slightly less brittle. So a couple of production tips that we've learned from running Device Farm for the last, I guess, 2.5 years. You should definitely check out private devices if you need a predictable startup time. We've been using the public Device Farm offering, I guess you could call it, for a couple of years now, and we're just shifting this way because we want to get the lowest possible startup time for our customers. It also means that we can get the right devices at the right time. So if we want a load of iPhone X's before Device Farm has shipped them and we can somehow get hold of them, great. Also, for some of our bigger customers, we'll end up shipping devices directly to Device Farm to put into our private cloud. The other thing to note is remote access can actually be automated. Should you actually want to connect not via the normal method, either in the web UI or local, you can do that. So that's a really powerful thing to do. The only caveat that I found with Device Farm, I've been super happy with it so far, is that today you can't allocate to individual instances of a phone. And so even with private device cloud, even if you know you have 10 phones, you can't allocate to a specific one. So for instance, if you're building to a specific UUID on your dev account, you can't do that. So it still needs to be re-signed. So yeah, watch out for that if that's important to you. OK. I think this is you now.
Yep. Well, thank you, Russ.
Oh, you're welcome.
So to summarize, during the entire thing that we covered, right from console to insight from Chandra and then Russ, so we got instant access to hundreds of devices in the public and private fleet. So we saw that. Support for automation. There were multiple testing frameworks, Appium, Calabash, instrumentation. Ability to run on multiple devices in parallel. Saves you tons of time if you're not going serially. And then support for manual testing. We didn't get a chance to do, but Russ, the video that Russ showed you how you can have a video. It showed the video on how it's clicking on stuff. So the manual testing is you can actually interact with the device inside a browser. Then we saw the Jenkins plugin. We also saw the reporting. So it grouped all of those unique failures, and you could quickly go to the problematic area in your app. You get access to all of the test artifacts, the videos that I showed, and all of the test logs. Those are all downloadable artifacts, even the one that you produce and are not offered as a standard part of the framework. And then all of those combination leads to faster debugging and bug resolution. So that's the summary for Device Farm. And I think that was the end of it. We can have questions, if any.
If you can come up to the mic, that would be great. There's a mic in each corridor.
Yeah.
Let's say we want to test a QA environment that is on-premises.
Uh-huh.
Is it possible to whitelist a range of
Yes, yes. So there are two ways you could. So the question is that they have an on-premise QA system, and you want to say, your devices should hit that internal on-premise QA system, right? That's one.
Yeah, let's say we have a fair firewall, one.
Yeah.
Only those IP.
Yes. So all of the public and private devices in Device Farm, they have a static IP range. So you can whitelist that. That's first option for the public and private. You could even have more involved system where your devices need to be exactly authenticated. You don't want any other device in the IP range to access it. So you can use private devices, have VPN clients installed in there, and then they can connect to your stuff. The third option is private devices has a feature called direct device access that we recently launched. It's a really neat feature, and it really needs more time apart from the scope of this session. Imagine today you have 5 devices connected to your machine. You do ADB devices, say, for example, on Android. That ADB device lists all the Android devices, right? So if you had 5 devices. Now imagine you had 20 devices in your private fleet. And what if you did ADB devices and all 20 devices show up, right? It's a zero friction way. You don't have to do anything. It's in your QA environment. You have that whitelisted, and nothing changes. So that's direct device access with private devices. So those are the 3 ways I would approach this, depending on what type of devices do you want. You need a dedicated fleet, a larger set. Most customers we see is as they approach the release cycle, they'll do a larger test, and then across the development cycle, they do smaller devices. Yeah. Anyone else? Yeah.
Yeah.
Yeah, go for it.
All right. Hi. Dan Arad from Lazemeter. You mentioned, or I saw at least online, there were a few options. One was, as you mentioned, the dedicated device, which means that I need to bet or decide on a specific device that I'm going to get at, and then I have access to the device itself. I can do whatever I want with it, relatively fast. And then there's the other one, which is in real time, I get access to whatever device I want, but then it takes time for the device to come up. It can be minutes or whatever, because you said you clean it up, et cetera.
Yeah.
When I'm looking what I'm looking for is actually something in between, which is already available in the regular servers or whatever, non-mobile, which is getting access to the device in real time, choosing whatever I want, being able to run with it and do whatever I want, maybe multiple tests. Because the on-demand is, if I understand correctly, I run a single test, and that's it. I'm back at square one. If I want to run another test, having to wait for everything to launch up. So something in the middle where I get access to the device, I do whatever I want with it for like 20 minutes, and whatever, I give it back to you, and then I have that flexibility.
Got it, okay. So some clarification. So the public devices, when I selected a device, right, for scheduling a test, they have multiple instances of each of those devices. So it's not that it has just one instance. So even if you had 200 tests and if you uploaded it, it's going to take one instance, run for the upper limit of 150 minutes if your tests run at that long, and then going to leave up the device. So it's not that the next customer waits for that device to get freed up. There are already other instances. So the customer comes in, gets to instance 1, instance 2, and we scale up. So that's the on-demand. For private device, it's more predictable, as Russ mentioned in one of his production tips, that because those devices are not shared across anyone, you know that that's only dedicated to you, so that's your on-demand model. And so I think the public device does scale up for your on-demand needs. So the in-between thing where you just need a device for an instance, if you want the higher predictable availability, private devices do scale. And the public devices wait for 24 hours before they actually give up. Does that answer the question?
So I'm looking for not one long test, but I'm looking for multiple relatively short tests to run one after another. And I don't want to wait for...
I think I know what...
Sure, yeah, go ahead.
So short version is, it's up to you what you put in the test you execute. So you upload a script when you use Device Farm like that. You can put 1 test or 50 tests in there. The problem is it won't be parallelized, but yeah, you can keep it for longer if you want. And I think that's what you're asking, right? But no, they don't chain different tests together on the same device necessarily. They always clean it after each test. It's up to you what you put in a unit test, though. So you can put like 1 thing or 50 things and just hold it for longer. So it might be more efficient somehow, but you should try it.
So if the reserved instance is like getting the machine, and I can do whatever, I'm not confined to a test, right? I can do whatever, but the on-demand is confined to a test, right?
No, both are the same.
Yeah.
You run a file. There's a test. You can put whatever you want in that test. Private devices, the only thing that's different is they're only used by you, and you get, obviously, priority over them. So you get them faster, there's less latency, there's no contention, but there's no difference other than that. today.
And then the one other thing is just to add, the private devices, if once they're made available on your machine or when you're trying to access them, they're always available. So it becomes your on-demand, becomes your entire private fleet is on-demand wherever you want it. And then you can do test sharding, another thing where you split your tests and run it, and what Russ said. Yep. I think we're short of time and done. Can you take? Yeah, we can take one more question.
Quick question, just is there any state-of-the-art today in terms of actually having a user click through a set of tests, record that and play back,
yeah.
regression test quickly?
Yeah.
So we did so there might be other solutions, but the one that I know, the standardized ones, we did a workshop yesterday, which was Android provides what they call as Espresso Recorder, and iOS provides what they call as XCUI Recorder, and it just brings up a simulator, or you can even use a device farm device in your local machine and record your interactions, and it will generate the test code for you, and then you just upload it. So if you had a CI system built in, you say, okay, I'm going to click this, that becomes your test package. It's going to build it automatically for you, deploy it on device farm, and do everything. So for you, it's as simple as record it, done, and you're going to just get the results of the entire test on device farm.
If you come talk to me afterwards, I'll tell you about some other stuff that we're working on.
Yeah. Cool. The other gentleman had a question. Yeah.
I was wondering if they're integrated with organizations so that we could have a large farm associated with an organization which may have 20, 30 apps. Some apps are closer to production, so we want to isolate some just to that group within the organization.
So you're talking about management of devices within the organization?
Yes.
Yeah, so on the public fleet, all the devices are available to your entire, say, AWS account. Right? So if you had one enterprise-level AWS account, all the devices are associated with that. You don't really segregate those devices types because all of those devices are available for everyone. For private devices, so what you can do is you can have projects, and then those projects can have device pools. So we can give access to multiple accounts to a private device fleet first. So if you don't have an enterprise federated, a main account. And if you have multiple accounts, we can do the private fleet share across accounts. That's one way. The second is you can have multiple projects and say, okay, these set of 5 devices belong to this project, and this team uses that, and nothing else. So that's another way to manage it, that you say these devices are only available for one project. So does that answer the question?
And I would say another way is you could have, if it works for you, you could have multiple accounts, one account, AWS account per team, and then you could allocate the devices that you want for that team to just that team, and that way it'll only be visible to them. I mean, so customers have used different mechanisms to manage the devices, but yeah, this is a very common use case that we get.
So it could be global, it could be singular.
Yes,
yep.
Yes.
Absolutely.
Yes. All right.
We had a question at the front.
Yeah.
Yeah, so my question is more around responsive web app.
Sorry.
Okay.
Hang on.
Go ahead.
This lady was...
Sorry, go ahead.
So okay, I'll let you complete. Yeah, so, so your question is, can you do continuous integration with code pipeline? Yes. So the way is we have the Jenkins plugin. It would entail you using the CLI or the SDK, because the CLI tells you whatever I did in the console, you can do it with the CLI or the SDK. So I've seen many customers do it. They do either that one-time script writing where they say, okay, I'm going to take my app from here, I'm going to upload it, schedule the run, and go. And then that can integrate within your code pipeline or other CI systems. So we've seen customers do it in Bamboo CI system or any other systems of choice. We also have a Gradle plugin. So if you can trigger the whole build via Gradle, that's another option to do it. But yes, I don't see a restriction. The plugin just makes it more easier, but there's no restriction. It's as simple as long as you can run maybe, say, Java code, Ruby code, Python code, or just shell script, you're good enough to integrate that in CI. So do you recommend Jenkins? What? Do you recommend Jenkins? Well, and so we want to cover all customer types and all, we listen to customers. Roughly 90% of our roadmap is driven by customer feedback. Jenkins was one of the highest asked integrations. And we listen to customers, and okay, if customers are asking for other system standard integrations, we do listen, so yeah.
So the question is more around responsive web app testing. So in addition to the form factor like tablets and regular mobile phone, if I want to also test different browser versions like Chrome versus Firefox, I know you showed where you can add additional boundary apps that you would require, but how do you support the multiple versions of browsers on a single or across
on a single device? So today, the Pure App web application works against Chrome browser and Safari. So for Android and iOS, that's the default nature today. Because of the testing frameworks that we have, because we have Appium, Calabash, and those support that. Private devices would be the way, because private devices gives you a zero friction way. So you can say, here's my browser, Firefox, or whichever one you said, and you can have those configured on the device. And as long as you have a way to run that test against that local device running Firefox, you're good.
We're being asked to wrap up. So if you have more questions for us, please come on up or come outside and talk to us there.